So welcome everybody, my name is Cormac Hogan. I do tech marketing for storage at VMware. I'm co-presenting this afternoon with Nathan Small. He's the escalation engineer for storage in the Americas. And we're going to look at vSphere 5.0 new storage features in this session. There's quite a lot, so we'll get straight into it. I'm sure you've seen the disclaimer more than enough times already. And I think you've probably seen this slide more than enough times as well. Obviously, the storage would play a major part of your infrastructure focus on your journey to the cloud. I'm sorry? Oh, could we turn up the volume, please? Okay. So just by way of introduction, I just want to give you an overview of the vision we had for 5.0 storage features and what VMware were trying to achieve with the introduction of these many new features that we've brought in. Essentially what we're trying to do is remove a lot of the complexity that vSphere administrators have when they're dealing with storage. So there's a lot of things that we've done. The first thing we've done is we've tried to make the number of storage objects that you're dealing with much less. So when you see the new scalability features that we've added to VMFS 5, where we're heading towards is having fewer very large LUNs as opposed to lots and lots of very small LUNs. The other thing we've done is we've enhanced a number of features that already existed in previous versions of vSphere, particularly around vStorage APIs for array integration. So we've extended those, and we'll talk about those as well. There are some new APIs introduced as well for storage. We're going to cover those. One of the big concerns for our customers is, where do you provision your virtual machines? Am I selecting the correct storage? And what you'll see is we have introduced a feature called profile-driven storage, which is greatly going to assist in determining which is the best data store for placing your virtual machine. And it means that every time you provision a virtual machine, if you're using these profiles, you're going to select the correct storage each and every time. So it'll make that selection of a data store for your virtual machine error-free. And finally, we're trying to reduce a lot of the time-consuming tasks that administrators have, especially in the area of provisioning storage. So the fact is, if we can scale out our data stores, we won't have to provision quite so many of those. So we also put ourselves in the position of a vSphere administrator, and what are the concerns that a vSphere administrator has when they're dealing with their storage? So we've listed a number of these here. Obviously, the one I mentioned already is where do we place our virtual machine? Are we selecting the data store that's got the correct capabilities? Has it got the correct underlying RAID level? Is it replicated in the case of SRM? Am I selecting the correct replicated LUN for my virtual machine? A lot of these things are very tedious for administrators right now, and a lot of the time you have to engage with a SAN administrator to try and figure out what is the correct data store. Does it have the capabilities I need? What we're trying to do is surface a lot of these into vCenter, so it makes this selection process much easier. Also, throughout the lifetime of a virtual machine, it's sitting on a data store, and administrators are constantly have to monitor these data stores, both for capacity, space usage, and also for performance and latency. So these are very time consuming as well. Mentioned also about the fact that you have to physically present LUNs. So as your storage consumption is growing, you maybe have to provision more and more LUNs. If you're dealing with a very large cluster of ESX servers, you have to make sure that these LUNs are presented to all the ESX servers in much the same way. And that becomes even more involved if you're dealing with extents. So, VMFS data stores that are made up of multiple LUNs. And if you have those LUNs to be presented to lots of ESX servers, that becomes a very tedious thing to achieve. And then, of course, you might be very diligent and you might place your virtual machine on the correct data store to begin with, but maybe somebody else in your organization does a cold migration or a storage vMotion of that virtual machine onto another data store that doesn't have those correct capabilities that you needed for that VM. So these are all the kind of concerns that a vSphere administrator would have around storage. And that's what we're trying to address in 5.0. We're trying to address all these concerns and automate them as much as possible for the vSphere administrator as well. There are two other quite large concerns for vSphere administrator when it comes to storage, and that's around thin provisioning. There are two thin provisioning concerns in particular that are highlighted here. The first one is, I've got a thin provision data store. I have lots of virtual machines running on that data store. What if I run out of space? What's going to happen to the virtual machines? What's going to happen to my data store? That's a major concern. The other concern we have is a vSphere administrator would have, is the inability to inform the storage array that blocks that I was previously using on the data store, I'm no longer using. So for instance, if I'm deploying virtual machines onto the data store, which is thin provisioned, and then deleting that virtual machine or storage vMotioning that virtual machine to a completely different data store, how can I tell the storage array that I'm no longer using these blocks? So these are two major concerns, and we'll show you as well how we're addressing those concerns in the 5.0 storage features. So I'm going to hand you over to Nathan. He's going to take you through the enhancements we've made to VMFS 5 and also the enhancements we've made to the storage APIs for array integration. And I'll come back and I'll talk to you after that. There you go.
Thanks, Cormac. Can everybody hear me? Good. So let's talk about VMFS 5. A lot of really good new things have been added. A lot of things people have been asking for. Right here we've got a feature sheet showing the difference between VMFS 3 and VMFS 5. I'm going to go through each one. So the first one is, yes, now you can have 64 terabytes, single LUN, single extend. Before, in order to achieve that, you needed to have 32 2-terabyte volumes and then stitch them all together. Okay? So that was a big win. Now, working in the Genius Bar, as well as some of the sessions that we've been part of, the group discussions, there's been a lot of concern about having a data store that big. Customers have been saying, if I have a data store that big, what are the concerns I should have? Like, well, the first one would be the actual queue depth on the array side, right? There's a big difference between taking, 61 terabyte LUNs, amalgamating them all to one and throwing all your VMs on there. You're going to hit some queue depth maximums pretty fast. Not only on the array side, but also on the host. The HBA queue depths are, by default, if it's QLogic, it's 32. Emulex, it's 30. I don't know what Brocade is. Probably one of those two as well. So those are some things to keep in mind. So we allow you the ability to go very, very large. Just keep in mind when it comes down to queue depths and whatnot, that you're not going to create your own bottleneck. Okay? The next one is support for more files. So based on the old data store design, we were able to have around 30,000 files. We've now extended that to 130,000, so 100,000 more than we had before. We also have support for 64 terabyte physical mode RDMs. Okay? Physical mode, not virtual mode. Mostly because that would, if you're in virtual mode, that allows you to use snapshots, right? Physical mode does not allow you to have those. So we don't get into an issue where you're going to have a file that's going to grow past 2 terabytes minus 512, which is still the file size limitation of that volume. The next is unified block size. So we changed the way that we did pointer blocks from a file system perspective. So you can now address 2 terabytes minus 512 with 1 meg block size. Okay? The next one is atomic test and set. So in 4.1, we introduced the VAAI features, hardware-assisted locking, cloning operations, and whatnot. But they were limited in the sense that from an atomic test and set perspective, we would use it if we could, but if there was 2 in flight at the exact same time, they would kind of cancel each other out, and we'd revert to using SCSI reserves for that operation. In VMFS 5, we have retry mechanisms to ensure that that doesn't happen, so it's now unlimited. It's full use of ATS through and through. Next, we changed the size for subblocks. VMFS 3 was 64, which meant we only had about 3,000 of them. We've changed that to 8K, okay? Which allowed us to have about 30,000, 10 times as much. And then finally, small file support. So before, if you had a very tiny file, a very simple VMX file, that would occupy a subblock, okay? Now if it's under 1K, we do support that. It will exist within that 1K size until it grows past there, okay? As far as upgrade is concerned. Some of these features, if you do a VMFS 3 upgrade, you will not be able to get. The examples we can see here is the total number of files. You're still locked in at 30,000. Your subblocks don't change as well. And neither does your block size. It will remain at whatever it was before. If it was 1 meg before, it stays 1 meg. If it was 8 megs, it stays at 8. What's the downside there? The downside of that would be actual space utilization. Okay? Subblock also remains the same, and there would still not be any small file support, I believe, right?
No, I think we do get small file support with the upgrade. I think we do, yeah.
So kind of the best practice that we recommend is with ESX5, if you're going to create a VMFS 5, or if you're going to move to vSphere 5, as part of best practices, we would recommend to create a VMFS 5 data store and then storage vMotion your VMs to it. You still get the ability to do 64 terabyte volumes, as well as the RDMs. It's just the little caveats here and there. So that's just a heads up. From this screen, we can see that we have two options in vSphere 5. You can create VMFS 5 volumes, which can only be seen by ESX5 hosts, or we have the legacy mode, which allows us to create VMFS 3 volumes for mixed environments. The other thing, obviously, in order for us to be able to address more than 2 terabytes, we had to move away from MBR.
Okay. So I give him a chance to drink some water. So with VMFS 3, we use the MBR, the master boot record. That has a limitation of 2 terabytes for a partition size. So obviously with the new 64 terabyte VMFS 5 volume, we needed a new partition format. So we've introduced GPT, the GUID partition table. And so you'll see it now as you go through the VMFS volume creation wizard. You'll see that there's a new partition type just there. All right.
Thanks, Cormac. All right. So working too much in the Genius Bar, I'm losing my voice. Right, so next slide. So if you wanted to upgrade and use that feature, you can do it non-disruptive. You can do it while virtual machines are running. It's right there in the vSphere client. Very simple, very straightforward. Like I mentioned before, the best practice that we're kind of recommending, especially if you want to take advantage of the features of more files, smaller subblocks, whatnot, create a new LUN, use storage vMotion, and get your data over to the new LUN. Very simple procedure to do, and with hardware-assisted copying and offloading with VAAI becomes a very fast operation. So let's talk about the changes in VAAI, what's been added. Brief overview, just to rehash, VAAI is hardware offloading to the array. Very simple. Okay? What did we address in vSphere 5? Well, we addressed the issues of or extending those abilities to NAS devices. We also, as Cormac mentioned earlier, we also did some changes to thin provisioning for out-of-space conditions, as well as reclaiming dead space. Or not dead space, but unused blocks. So the options that are available for NFS, we have full file clone, fast file clone, and reserve space. So you now have the ability to select what type of disk you'd like to have on NFS. Before it had to be thin. Now you can do thick and eager zero thick from the client. The full file clone is similar to the same option that was available for VMFS, which allows you to deploy templates or clone VM decays very, very fast. The last option, fast file clone, is basically integration with some of our vendors. NetApp and EMC, I believe. NetApp's Flex Clone technology. And what that does is that allows you to use their Flex clones instead of our own link clone technology for View and for vCloud Director in order to offload for their hardware abilities, but also so those link clones are aligned. Right? From an I/O perspective, that's a huge win. So this next slide will show you the difference between NAS with VAAI enabled and not enabled. So you can see right here, from your provisioning options, you have thin and thick and eager. But they're all grayed out. With it enabled, we can see that we have all the options right here. Okay? So the other thing is thin provisioning. The two issues that we're addressing is, in the past, if you ever did a delete operation, or you did a migration, whether that's a cold migrate or it's a storage vMotion, those blocks, from a thin LUN perspective, are still used because we have no way of telling the array that they're not being used anymore. Now we do. What we can tell the array, once we're done the operation, we can give it a logical block address list and say, we're done using those. And it can claim them back. In the past, in order to reclaim space, you'd have to basically evacuate your LUN, create a new one, and move everything over. Okay? So that was a big win. Oh, and the next one is the out of space condition. So I'll get into that in a little more detail, but for any one of us that has ever had a snapshot on a virtual machine and the data store ran out of space, that wasn't a good thing to happen. You might have a corrupt snapshot when you're done. I'll get into that a little bit later. So like I said earlier, if you're doing any sort of migration, you're deleting files, you're doing anything that you want that space reclaimed back, we'll use Storage vMotion as an example. Once it moves all the data, the old way would keep those blocks used. Now we can tell the array to take it back. Okay? Big feature. Now, if you have a existing environment and you want to reclaim the space, you absolutely can. You just need to go to vSphere 5 first, and then upgrade the volume to VMFS 5, and then run this command. And it'll reclaim all the space that it can. Okay? Now, the out-of-space condition, I kind of use the snapshot on a virtual machine as an example. In the past, if you ran out of space, from a thick data store perspective, you could have a corrupt snapshot. And then you have to call support, and we'll try to fix it for you if we can. But when you have a thin LUN that's supposed to be transparent to the ESX host, we don't know when it's going to run out of space. Right? We just keep allocating more blocks and using as needed. We now have an ability to talk to the array and figure out if we are actually running out of space. When we do run out of space, or we're going to run out of space, we can stun the VM. And that's only a VM that's requesting additional blocks. The big advantage is here, yes, you've got a VM that's stunned. Maybe not the best thing in the world, but it's better than trying to write past blocks that we do not have allocated and prevent it from allocating any more. This will leave the LUN online on the array side. It allows us, while it's stunned, to make more space available. Okay? Whether you migrate, whether you delete, whatever solution you want. And then you can resume the VM. Okay? So just to rehash what we talked about, so reclaiming dead space. In the past, well, I guess even right now, there are some arrays out there that have a feature called Reclaim 0. And you have to take specific measures in order to get that space back. Now we don't need to do that. Now once we're done the operation, we give it a logical block address list, and it takes it back for you. Next is handling out-of-space conditions far better. Okay? Stun the VM, prevent it from going down hard, keeping the LUN online, and preserving your data. Now I'll hand it back to Cormac.
Give your voice a rest. So, thanks, Nate. So what Nathan has been discussing there are enhancements to technologies that we've already had, VMFS 3 to VMFS 5, and we also had the hardware primitives for offloading to the array. What I'm going to talk to you now over the next 3 topics, they're all brand new, newly introduced in vSphere 5.0. The first of these is a feature called VASA, or the Storage APIs for Storage Awareness. And this is where we're working very closely with our storage partners to surface the capabilities of the LUNs up inside in vCenter. Right now we see some information like the array model, the NAAID, the SCSI identifier, but a lot of that isn't very useful because you don't know the capabilities of the actual LUNs. What VASA is going to do for us is it's going to surface up capabilities such as perhaps the underlying RAID level, whether the LUN is tin provisioned or not, is it a dedupe LUN? All those kind of things can be now surfaced up, and when you look at the data stores inside in vCenter, you can actually see those capabilities being associated with the data store, the underlying LUN. So how it works is, as I said, we're working with our storage partners, and what they're doing is they're developing a plugin which will, I don't know if any of you have been working with the 5.0 beta or just installed the 5.0 GA version, but you'll notice on the main screen that there's a storage providers icon. And this is essentially where you add in details about the storage partners vendor plugin. And so this plugin, or vendor provider, to use the correct term, is a piece of glue that sits between the storage array and vCenter and actually pulls the information from the storage array about the LUN's capabilities and then presents those to vCenter. If vCenter finds a LUN, when you do a rescan of the SAN, and it discovers a LUN that also is known by the VASA provider, then those capabilities are now shown inside the vCenter UE. So we're leaving the storage vendors decide for themselves what type of information they'd like to surface up, but typically the kind of things we're expecting to show up in vCenter are things like the RAID level, whether the LUN is replicated or not replicated, dedupe, as I mentioned as well. So this is going to be very useful for vSphere administrators who are trying to figure out what the underlying storage capabilities of the LUNs are when it comes to deploying the virtual machines. So this is, as I mentioned at the very beginning, one of the primary objectives of the storage enhancements that we've done to 5.0 is to make the life of a storage administrator, or a vSphere administrator, much easier from a storage perspective. So we've seen in the past where customers have maintained these spreadsheets of storage capabilities so that when you see a particular NAAID, you just have to go to your spreadsheet and find out what the capabilities are. We've also seen customers use really strange naming conventions of data stores to try and understand what the underlying capabilities are as well. So with VASA, what we're hoping to achieve is that you won't have to go to this unnecessary additional administration. Now you'll be able to see these storage capabilities surface right up inside in vCenter. One of the really cool things about VASA is that it does show us these storage capabilities. What we can then do with the next feature, profile-driven storage, is we can actually start to build up profiles of the various capabilities. So for instance, if you wanted to deploy a virtual machine onto replicated storage, and the storage capability being surfaced by VASA would tell you whether the LUN was replicated or not, you can then use this profile to associate with a virtual machine, and what it will allow you to do is make sure each and every time that you are selecting a replicated data store for your virtual machine provisioning. So I'll take you through the steps on how VASA interacts with profile-driven storage, but VASA isn't a necessary component. You could actually create your own storage capabilities as well. For instance, you might like to use business tags such as gold, silver, and bronze to try and differentiate the different types of data stores. You could certainly do that as well. So essentially, it's basically to make the purpose of profile-driven storage is to make sure that your virtual machine provisioning is correct each and every time. You're going to select the correct data store. So, as I said, you can use it with VASA. It's definitely very complementary to use with VASA because you can build the profiles out of the storage capabilities that VASA is surfacing. But of course, you could also go ahead and build these user-defined capabilities as well. The great thing about the profiles is that they're permanently associated with the virtual machine. So it's not just for initial placement. It's great for initial placement because you will select the virtual machine. But remember, one of the things I said that a vSphere administrator has to do is constantly check that a virtual machine is on the correct data store throughout its lifetime. Well, the fact is that somebody could storage vMotion, that virtual machine, to another data store that doesn't have the capabilities very easily. With profile-driven storage and the associated profile with the virtual machine, you can constantly check whether a virtual machine remains compliant. In other words, the profile that's associated with the virtual machine has got the same capabilities as the data store on which the virtual machine is placed. If they match, you're going to see a compliance state of green or OK or whatever. But if the virtual machine is put on a data store that doesn't have the capabilities that are defined in the profile for the virtual machine, then you're going to see a non-compliant state. So essentially how it works is like this. We start off with a data store that has capabilities. Now, as I mentioned, these can come from VASA, or you can define them yourself. They can be like the business tags I mentioned of gold, silver, and bronze. So our data store has the capabilities. We then go ahead and we create a profile. And what goes into a profile is a set of capabilities as well. Again, these can be physical underlying storage capabilities like RAID level or replicated LUN or dedupe or whatever the case may be, or they could be these business defined tags. When we're provisioning a virtual machine, or later on, you can actually attach these profiles to an already existing virtual machine if you so wish as well. But let's say we're provisioning a brand new virtual machine and we attach the profile to it. What you're going to get is a selection of data stores which meet the storage capabilities and a selection of data stores that do not meet the storage capabilities. Now, we're not preventing you from selecting a data store that doesn't match. You can certainly go ahead and do that. There may be reasons why you want to select a data store that doesn't have the correct capabilities. But the fact is that once that profile is attached to that virtual machine, it'll make the selection of the underlying data store very clear, crystal clear in fact, because what happens is that the data stores on your host are broken out into two sections, the compliant data stores and the non-compliant data stores. So if you put the virtual machine on a compliant data store, it obviously goes green. If you put the virtual machine on a non-compliant data store, it's red. So that's essentially how it works. It's just a matching of capabilities. But it's not just for initial placement, as I said. Throughout the life cycle of that virtual machine now, you can constantly check to make sure that it's on the correct storage from a capabilities perspective. So how it looks like is this. Hopefully you can see that. But when we select a virtual machine now in vSphere 5.0 in vCenter, there is a new window in the summary tab of the virtual machine, and this is a storage profiles or VM storage profiles tab. And in that box, you can see at a glance whether your virtual machine is residing on a data store that meets the capabilities of the profile that you've defined. If you don't, then obviously this will be red and it'll be in a non-compliant state, but in this case it is compliant. Now it might be a bit of a drag to actually go through every single virtual machine to check is it compliant or not, but the fact is that we do have a new feature, but there's a new icon in the main vCenter screen as well for VM storage profiles, and you can go in there and against every single profile it will list all the virtual machines that are associated with that profile, and it will tell you whether they're compliant or not compliant. So for instance here you can see that I've selected a particular profile and I have a number of virtual machines, well in this case 2 virtual machines associated with that profile. Once again, they're all compliant, but at a glance you could tell whether they're not compliant or as well. The other thing is where you could have multiple VMDKs associated with each virtual machine, obviously. Each of those can be associated with a different profile as well. So you could have a particular set of capabilities that you want your base OS disk to use, and then you might have a different set of capabilities for your data disks. So this brings me on to the third new feature. This is Storage DRS. All I can hope to do in this presentation is give you an appreciation really for what Storage DRS does. There are a number of deep dive presentations that have taken place and are continue to take place throughout the VMworld. But let's go through it anyway, just give you an appreciation. So again, we're harking back to this this scenario that I described to you at the very beginning, where we're trying to make the life of a storage or vSphere administrator much easier from a storage perspective. So let's take a situation where we are without 5.0 in previous versions of vSphere. When it comes to virtual machine deployment, you're manually identifying a data store that might have perhaps the most amount of free space. Then you're trying to look at the performance of that data store, make sure that the latency isn't too high. So if you're going to push down another virtual machine, you've got to make sure that the data store will still perform. And then you might have a situation where you have a primary DNS server and a secondary DNS server or something like that. You want to make sure that they're kept on separate data stores, because if you lose one data store, you don't want to lose both the primary and secondary of whatever application you have. Or you can do what a lot of us do, and I'll just deploy it anywhere. We'll see how it goes, right? So what's Storage DRS going to give us? Well, Storage DRS each and every time is going to select the best data store for your virtual machine based on two factors: amount of free space and the latency. So automatically you have this feature that's going to tell you this is the best data store for your virtual machine. This is the optimal data store. Throughout the life cycle then, or the lifetime of that virtual machine, Storage DRS is continuously going to be checking the space consumption and the latency of the data stores and recommending to you, well, it depends whether the Storage DRS cluster is in manual mode or automatic mode, but if it's in manual mode, it's just like DRS for CPU memory usage. It's going to surface up recommendations for you to act on. And these recommendations are basically storage vMotions of the virtual machines around the data stores that are in Storage DRS. And it does that based, once again, on space consumption capacity and on the performance or latency of the data stores. There's also some really good placement rules. Again, if you're familiar with DRS, you'll be familiar with the affinity, anti-affinity type rules, where you can keep virtual machines together or virtual machines apart on different hosts. Well, in Storage DRS, we have the exact same concept, except this time it's on data stores. Keep virtual machines together on the same data store, or keep them on completely separate data stores. So that's what it's going to do for you. And again, it's going to make the life of a vSphere administrator so much easier, because it's getting rid of or automating a lot of the tasks that previously had to be done manually. So we'll get into some of the features of Storage DRS now, but conceptually, there is a component of Storage DRS which is known as a Datastore Cluster. Datastore Cluster is a group of data stores. However, when you enable Storage DRS and you select a particular data store cluster for Storage DRS, you're turning that data store cluster into a load balancing domain. So a virtual machine will then be deployed to a data store cluster as opposed to a data store. And this will be available, you'll see it in the virtual machine creation wizard. You'll get a list of data stores, but you'll now see a new object called the data store cluster when you do virtual machine provisioning. So once you have the data store cluster created, you're now ready to deploy your virtual machines onto it. Let's look at what else Storage DRS is going to do for you. So the first thing is the initial placement. So Storage DRS, as I said, will select the best data store for you in that data store cluster based on the capacity and the latency values of those data stores. So there are many algorithms running in the background, and it's going to take the best combination of those two features, the latency and the capacity, and select the best data store for you. So in this particular case, we're looking at space. This is a very simplified example, but you can see that I have one data store here that has 300 gigabytes of space. What I'm going to do is I'm going to initially deploy a new virtual machine and move it down onto the data store in the data store cluster that has the most amount of free space. We mentioned here about the affinity rules. I mentioned about virtual machines being kept together or virtual machines being kept apart. You can also set anti-affinity rules on the VM decays. So you can actually have a virtual machine with multiple VM decays, and if you set up an anti-affinity VM decay rule, those VM decays will be placed on separate data stores. So for instance, if you had a virtual machine where you used host-based mirroring, for example, inside in the guest, you'd want to make sure that the VM decays are in completely different data stores, because if they were on the same data store, you could bring down both sides of your mirror. The VM decay affinity rule in Storage DRS allows you to do that. So that's pretty neat. But by default, VM decays are kept together on the same data store by Storage DRS. That is the default. Load balancing then takes place throughout the life cycle of the virtual machine. Load balancing, once again, is basically storage vMotioning of virtual machines across the various data stores in the Datastore cluster to achieve the best balance based on capacity, space usage, and latency of the data stores. So again, a very simplified example. I have a number of data stores here in my Datastore cluster. You can see they have various latency values. I'm going to select the one that's got the lowest latency. In this case, it's 5 milliseconds. And so I might move a virtual machine off of one of the data stores that's got a high latency and move it to a data store with a low latency, just to get the balancing in the Storage DRS cluster once again. So again, a very simplified example. A really cool feature, the data store maintenance mode. Now for some time we've had host maintenance mode, and this is where if you had a DRS cluster in fully automated mode and you wanted to put one of the ESX servers into maintenance mode for whatever reason, we would automatically vMotion virtual machines onto the remaining ESX servers in the cluster. We can now do the same thing but based on data store. So if we have a fully automated Storage DRS cluster and we decide that we need to do maintenance on one of the data stores in that cluster, we just place that data store into maintenance mode and we will automatically storage vMotion the virtual machines off of that data store to the remaining data stores in the Datastore cluster, and that allows us then to work on whatever we need to do with that particular data store. So that's pretty cool as well. All right, so this is just really recapping on the rules. If you've used the DRS feature, again, very similar concept, except this time we're dealing with the virtual machines on a data store level. So we have these selection of rules. We have the VM decay affinity rule, which is basically keeping the VM decays together. We have the VM decay anti-affinity rule, keeping them separate, and we have a virtual machine anti-affinity rule as well, where we can keep virtual machines on separate data stores for whatever reason. So again, those of you familiar with DRS, a lot of the conceptual features that you get with DRS, we're also getting with Storage DRS. Great, so what I have here is just an example of one of these recommendations being surfaced up by Storage DRS. Again, in a fully automated cluster, we're trusting Storage DRS to do these decisions on your behalf, and it will take place in the background. However, and this is the exact same advice we gave back in the day when DRS came out, is we would make a recommendation of running Storage DRS in manual mode to begin with, and make sure that the recommendations that are surfacing up by Storage DRS make perfect sense to you. And then when you get to a level of comfort, confidence that Storage DRS is doing the right thing, you can consider moving it into automated mode. But just like we did with DRS when it first came out, make sure that the recommendations that it's telling you about the vMotions make perfect sense, and then you can consider moving to automated mode. Exactly the same approach we'd recommend with Storage DRS. The cool thing about the recommendations that are popping up is that it's going to tell you information about the source data store and the destination data store. So for instance, if there's a recommendation based on space utilization, it's going to tell you, I recommend that you storage vMotion this virtual machine from data store A, which currently has a certain amount of space used, to Datastore B, which has this much free space. So at a glance, you can see why it's making the recommendation. The same goes for the latency. So it's going to tell you, I recommend you move or you storage vMotion this virtual machine from Datastore A, which has this high latency, to Datastore B, which is this quite low latency. So it all appears in the recommendation. It's really quite good. Okay, let's see. Yeah, there we go. So you can see the latencies there as well. I'm not sure if you can see that quite clear, but it will appear in the recommendation that's surfaced up. All right, so if we bring all that together, VASA, we can see how VASA complements profile-driven storage. Profile-driven storage also complements storage DRS. If each of the data stores in the Datastore cluster has the same storage capabilities, which is what we would recommend, by the way, if they all have the same capabilities, then you can build a profile around those capabilities as well. So when it comes to the deployment of a virtual machine, and you start off with the initial placement, and you select a particular profile for that virtual machine, if all of the data stores in the Datastore cluster have the capabilities and match what's in that profile, then you'll be offered the storage, the Datastore cluster as a destination for your virtual machine placement as well. So you could have multiple Datastore clusters built up with different capabilities, and so once again, depending on which profile you select, you can select the correct Datastore cluster for your virtual machine. So they're all complementary technologies. Okay, and so you can see here we're just selecting a particular profile, and then you can see that the Datastore is compatible. In this case, it's a Datastore cluster that it's offering you as compatible. Okay, so I'm going to hand you back to Nathan. Hopefully his voice is back. And I'll come back to you and I'll talk to you towards the end of the presentation on the new vSphere storage appliance.
Thanks, Cormac. So I'm going to talk to you guys about storage vMotion, as well as FCoE. They're relatively quick slides. With vSphere, well, I guess what's called VAAI 3.5, storage vMotion was introduced. In order to get it to work, you had to either use the remote command line interface or the command line interface. In vSphere, we introduced the ability to do everything through the GUI. What we also introduced is something called CBT, or change block tracking, that enhanced the ability to do storage vMotions a lot quicker. In vSphere 5, what we've done is we've added the ability to do snapshots, virtual machines with snapshots, as well as link clones. For anybody that had a link clone and they storage vMotioned it either by accident or on purpose, what you got in the end was a full virtual machine. It was no longer a link clone. So we've now added the ability to do that. In addition to this, we've also done a change that surpasses CBT. When you do a storage vMotion, we'll actually mirror the I/O between the source and the destination as the virtual machine is running. What that gives us is it gives us the ability to do everything in a single file copy operation. That means it gets done quicker, and it means we can stun the VM less, if at all. Okay? So FCoE. So in vSphere 5, we introduced the software adapter. Okay? Much in the same way that you would select the iSCSI adapter, same sort of screen if you're going to add a storage adapter. Benefit of this, if you can team it up with certain devices that have FCoE offloading, you can reap that benefit as well. Just a heads up, just ensure when you are going to set this up for the very first time that it's end-to-end. Set up on the switch, enable FCO on the switch and on the array. Otherwise, you won't see your devices. And now I'm going to hand you back to Cormac for the VSA.
So that was quick. So we have one last topic that we want to talk to you about, and I know that we have been positioning the VSA, I guess, at the SMB type market, the small to mid-sized business. But I think once you see what it can do for you, there's lots of other opportunities for you to use the VSA as well. And you might have some kind of R&D type setup, or test or whatever, that maybe going to the expense of purchasing a brand new storage array just for a couple of ESX servers in order to do some testing, it may not be the right thing to do. I'm going to tell you now about the VSA, which allows you to take local storage from your ESXi servers and actually build out shared storage, which will then in turn give you the ability to do things like vMotion and set up vSphere HA as well. So, as I said, we're kind of aiming this really at the SMB market who may not be in a position to pay out for a physical storage array. So what we're going to do with it is essentially kind of do some bundling with some of our licensing schemes so that you get the VSA with the vSphere licensing. So essentially VSA is an acronym for the vSphere Storage Appliance. And as I said, it's aimed at the SMB market, and it's low cost, very easy to deploy, very resilient, and essentially an enabler for some of our vSphere core technologies like vMotion and vSphere HA. So I'll just do a building block here of what or how it all ties together. We essentially start off with either 2 or 3 ESXi 5.0 servers. So these are vanilla installed ESXi servers, and what we end up on the local storage is the boot partition, a scratch partition, and then the remainder of the disk is given over to a VMFS 5 file system. Once we have those vanilla ESXi servers rolled out, what we do during the install is we first of all create a plugin in vCenter. So one of the cool things is the storage management, or the installation and the storage management of the VSA afterwards is done through vCenter. So we push down what's essentially a plugin. Now what that does is it creates a brand new tab in your vCenter for managing the VSA. So we first of all start off with the installation. How do we achieve this? Well, we push down 3 appliances. In this case, it's a 3-node cluster, so we're going to push down 3, 1 to each ESXi server. If it was a 2-node, we would just push down 2 appliances. So essentially, they're just virtual machines. And what we do with these virtual machines is we give them lots and lots and lots of VMDKs to try and consume as much of the VMFS file system as they possibly can. So what you end up with is a very large virtual machine that essentially has all of the storage on the local VMFS file system. So this is then our VSA, or vSphere Storage Appliance. Once these VSAs have all the local storage, what we do to make it redundant, highly resilient, is we divide the storage in 2. So we end up with a primary and a secondary. And then to make it highly resilient, we mirror these volumes across the different ESXi servers. So server A would mirror to server B, B to C, and C back to A. What this means is that we could lose an appliance, we could lose a complete ESXi server. We've actually done demonstrations where we PSODed one of the ESXi servers, and the data stores that are inside in the VSA continue to be presented. They're not impacted in any way. So the presentation technology that we use, they're NFS data stores, and essentially what they do is from each of the appliances, they become NFS servers. They present out one NFS data store each, and those NFS data stores are automatically presented back to all of the ESXi servers that are participating in the cluster. So each of the ESXi servers here will see 3 NFS data stores. And now, because we have shared storage, we can do vSphere HA, we can do vMotion, we can do all that other good stuff that we need shared storage to do. So it's really quite neat. We have a number of demos, we have eval guides, we have a lot of information out there. So as I said, although we're gearing it at the SMB market, I think we'll find lots of other uses, and hopefully you will as well, for this storage appliance. So I think we're near the end. I suppose just in conclusion, hopefully this presentation has given you an idea of all the kind of things that we've done in vSphere 5.0 to try and address a lot of the management concerns maybe that you've had with dealing with storage previously. And then hopefully you evaluate those features for yourself and have a good experience. So that's about it from myself and Nathan. I think we can take some questions now. If we have about 10 minutes, I guess. So if there's any questions, please just head up to the microphone and feel free to ask.
Question for you concerning NFS data storage.
Sure, sorry. Could we turn down the lights? Would that be okay?
Short of going through the new maintenance mode, is there any way to discover clutter on an NFS data store? We have a consistent problem with people not deleting from disk but simply removing from inventory, and then there's files on the data stores that nobody knows about. It gets to be rather difficult to find out which ones are real and which ones are not.
I understand your issue. I don't think we have anything of identifying. Okay, so somebody made a recommendation, RV Tools. I don't know if you're familiar with that.
No, is that a third-party tool?
There's a chap here who's going to tell you all about it.
It's free, it's downloadable over to my guy. It's really cool. It's really good product.
Okay.
Thanks.
Yeah, I think you two should hook up.
Yeah, I think that they just released a new version of that quite recently. Was it yesterday or something? I think I saw something about a new release of that just out. Yeah. Okay, thanks. Another question?
Sure, I have a question. I'm curious about the impact of using storage profiles on individual VMDKs on storage DRS. I mean, if I've gone through and assigned, say, my transaction log VMDK to some RAID 1 disk and another volume to RAID 5 disk, and I've got different storage profiles associated with different storage clusters. Mm-hmm. Is that going to be taken into consideration during the DRS?
Yeah, so you can have VMDKs of the same virtual machine sitting in different storage DRS clusters. That's and so in that case, if you wanted two completely separate data store clusters, one with your RAID 1 data stores, the other with your RAID 5, that's certainly achievable as well.
So during a DRS, it would only move the
VMDK or
the VMDK for in an individual.
Absolutely, it has that level of granularity. Yes.
Okay, thanks.
You're welcome.
In regards to the dead space reclamation, you had a command line that was up there before. Is the dead space reclamation a manual process that we're going to have to script somehow, or is that actually automated?
So it's a manual process if you're upgrading from VMFS 3 to 5. Okay, if you want to reclaim that space, that's how you would do it. VMFS 5 out of the box will do it if it's capable. So it's only doing when you do the upgrade.
Okay, so is it, if you have a VMFS volume that was version 3 and you did the upgrade to 5, is it then automated or is it still scripted because it was the upgrade?
No, you still have to run the vmkfs tools command. I think it's -y, I believe.
That's it, yes. So you have to run that command to do the reclaim of the space.
But that's forever permanent. Even if it was 3 and I upgraded to 5, 3 months later, I still have to.
I got you. No, so that's just once you've moved from 3 to 5.
Okay.
And that will reclaim any dead space that was there previously. But then once you're on VMFS 5, any of the delete operations that you do after that, that will be automated.
Okay. Thank you.
You're welcome.
Hi. What would be the compelling reasons to go with NAS data stores over traditional fibre channel if you've got both?
I don't think we've long enough, to be honest. That's a very kind of one of these long questions that you could discuss over beers and stuff like that. I don't think there's any right answer. It's a lot of it comes down to preference.
Yeah.
I guess dedupe, would that be a good reason?
Yeah, I mean, it's a different file system altogether. If you want, that's a good question for the Genius Bar or maybe afterwards we can have a discussion, but yeah, it's a little more involved than just which one do you prefer, right?
Are there any caveats in mixing VMFS3 and VMFS5 in the DRS clusters? Can you use both? Or
So the only thing that you can certainly mix both. So you can put VMFS3 and VMFS5 into the same data store cluster. That's not a problem. You cannot mix NAS and VMFS, but you can certainly mix versions of VMFS. The one caveat would be if you're also using array integration primitives, VAAI. And so when we do storage vMotions, the best performance is when we can offload those things to the array. If you have a mixture of block sizes, we have to do that in the VM kernel. So if you had a VMFS3 that was maybe 2 megabyte, and you had your VMFS5 with the new unified 1 megabyte file block size, it'll work fine, but you're doing the storage vMotions in the VM kernel data mover as opposed to offloading them to the array. And so that would be the only thing to keep in the back of your mind.
Thank you.
You're welcome.
Quick question here. You just mentioned that on VMFS5, the space reclamation happened automatically. Is it something that happened on periodic basis, or is there a command that needs to be executed, or how that process? So
it's basically on every delete or move operation. So essentially, if you're deleting files, there's an automatic call. It's a SCSI unmap operation that goes on in the background, and that's sent directly to the array with a list of LBAs to say, hey, reclaim these. So it's basically on a storage vMotion or any delete operation, it's an automated thing immediately after that, as it's actually part of the operation now.
Okay, and if the stun command is actually, the check condition is bound to the unmap.
I'm sorry, could you repeat that?
The check condition stun, well, the stun on VM, is it bound to that space reclamation process?
So it's bound to VAAI. It's an array. It's one of the new enhancements to VAAI. And essentially, as the data store gets full and there's a request for an additional block, we're aware now that the data store is full. And so when we go to request a new block, we know that there's no more space left on that data store, then the stun operation takes place. Was that the question?
Well, I guess it's kind of vice versa. So if you actually receive the stun from the storage, so would you initiate a unmap or, well, that space reclamation process?
So essentially the virtual machine with the stun operation is suspended until there's more space comes available. So yes, you could maybe do a storage vMotion operation to move some of the other virtual machines perhaps off that data store to a data store with new space. But once you have new space available on that data store, you can resume the virtual machine. It just needs new disk space or additional disk space to what's already there.
Okay, thank you.
You're welcome. Okay. Go ahead.
For the information that the array manufacturers are going to publish through VASA, is there a minimum set that they're going to pass, or is it completely up to them?
It's completely up to them, but there's a blog actually on our site here, which is a sneak preview at what some of the vendors are doing. Okay. So if you get an opportunity, pop on there. I think it was published a week or two ago. Okay. And you'll see what they're kind of heading towards. A lot of it is very similar, but some of the array vendors are putting their own nuances on it. Yeah.
And do they, when they pass that information, do they claim some kind of class of storage like gold, silver, or bronze, or does the user still go in?
So you would define that in your profile. So okay. You might like to have, RAID 10 and I don't know, whatever the capabilities are to be your gold, but all you would do then is you would create maybe a profile called gold and pop those capabilities into it.
Okay. Thank you.
You're welcome.
You said you recommended having the largest data store as possible. If you have a large array, is there any benefits to making clusters with smaller sized data stores, or just make the largest data stores as possible and throw them in one cluster together?
Well, like I mentioned earlier, you can go with very large data store sizes. The problem you're going to run into is, like I mentioned earlier, it's a queue depth issue, right? Whether it's at the HBA level on the ESX host or on the array port itself. Okay, so as long as you're within those numbers, you can create a comfortable size, right? But you just don't want to create a bottleneck somewhere, whether it's the array or it's the host side. I mean, from the host perspective, from an HBA, you can crank up the device queue depth, which is the LUN queue depth. The only reason you wouldn't want to do that is if you have a large number of LUNs and a large number of paths, you can actually reduce your heap, but that's a separate discussion. But it's just keeping in mind where your ceiling is, right? Because if you create your data store too big and you put too many VMs on them and they're doing too much I/O, your performance is not going to be good, and you might ask yourself why. Okay?
Okay, thanks.
Would VSA also work with 2 nodes?
Yes. The difference with a 2-node and a 3-node VSA cluster is that to avoid split brain situations, we stick a VSA service onto the vCenter server, and that behaves as your quorum. But certainly, yeah, 2 nodes or 3 nodes are the supported configs.
Thank you.
In terms of FCoE, you mentioned that was for the host side, right? Is FCoE supported in the guest, in the VM?
Well, just like the Microsoft software initiator that you run on the guest, it's transparent to us.
Okay.
Right? So, I mean, if one exists, then go ahead and use it. It's just network traffic. So it's transparent as far as we're concerned.
And did guest side fiber channel make any improvements?
NPIV, is it?
Yeah.
No.
So that's pretty much the same as 4?
Unfortunately, yes.
Can you vMotion a VM that has NPIV enabled? Because I can't find that in your docs anywhere.
That's a great question. I'm not sure.
Wow, I stumped the storage guy.
I know. You come up and get a book. There's a book here for you.
I'll come get it. What was it? What?
And get a Duncan and Frank's storage DRS book.
As long as it's mapped to all the ESX hosts.
Yeah, I think you can do it. I'm pretty sure. I think that was actually on the VCP4 test.
Oh, okay.
Yeah.
There you
so
go,
I think
man.
you can do it. Yeah, they just have to all be mapped.
Unfortunately, ladies and gentlemen, we have to end this session at this time.
Okay.
Thank you.